So hello and welcome friends to our channel Intro Mech, where we discuss about basic mechanical engineering concepts and so many other things which are related to our industrial automation field. So guys, we have started our new series related to the robotics, the industrial robots, what are the different types, their terminologies, basics and everything. And if you did not check the previous videos, please do check out the previous two videos in which we have discussed what are joints, links, then what are the motions, all those things you will require. So in our today's session, we will discuss some basic terminology, some terms those are required while selecting a robo or when we go to select a robo, when we refer some catalogs, then some data will be there, and it is important that we should know these terminologies so that we can better understand what kind of robot configuration we are selecting and whether it is okay or not. So without wasting time, let's get started. So what are the important terminologies? The first one is payload capacity, which is the most important parameter, I would say, because it refers to the robot's specified ability to lift the maximum payload at its extreme horizontal and vertical reaches. So whenever you select some robot, it will be having some extreme positions, it will be having the movements of the end of arm tooling or the wrist, and whatever tooling you are attaching to the robot, so it will be moving to the extreme positions. Now at these extreme positions, it will be having some speeds, so it will have some restrictions on the payload. That means how much load it can lift or how much load it can bear at its wrist, so that it can give the proper accuracy, repeatability at our required speed. So this is very important parameter. Then the second important parameter is workspace, which is also called as a work envelope, and it is the maximum horizontal and vertical reach of the robot to constitute its envelope. So as we discussed, the robot will be having some joints and links, and they will be having some restrictions. They cannot move further a specified point, and that will be in a space. So depending on whether you have a xy planar robo or a three-dimensional robo, the it will form some envelope, a 3D space you can imagine, with whatever maximum reaches it has, and that is nothing but a work envelope. Don't worry, at this point you might not get these points, but just try to understand it. As we move further, you will definitely understand what are these terminologies and why it is important to learn these terminologies at this point, because when we move ahead in the selection or in the catalog, you will see these terms, and at that point it will easy for you to understand. Then the accuracy, so it specifies the minimum error with which the robot can reach to a specified position. So you will be programming the robot so that it can reach to a specified position. Now if you want to move the robot to x position, and the accuracy, let's say a 10 micron or 15 micron, then when it reaches to that position, it the error, the required position and the actual current position of the robot, that should be within your limit, let's say 10 micron or 15 micron. That is the accuracy the robot can give you, that accuracy. Then the repeatability. Now repeatability is a very important term, and you will definitely find this uh, term when you select the robo in the catalog, and that is given in plus minus, let's say 10 micron, 20 micron, 50 micron, depending on which kind of robo you have, what are its drives, whether it has a servo drive or let's say stepper drives, because those things define its repeatability. That means uh, it refers, let's say, its ability to return to the same position again and again, because when generally you are using a robo, it will be working in a cycles. It has to go from x point to y point, then again it will come to x point, then again it will go to y point. So that is your cycle. So let's say in 1 hour you are doing this for 20 times, so in each cycle for 20 times it should reach to y position at a exact y position or within that tolerance. So that is nothing but the repeatability. Then the speed of the robot. Now the different configurations will have different speeds. Some will support high speed with the minimum vibrations, because that is also an important factor. When you have high speeds, the inertia of the part, the inertia of the end of arm tooling, those things you need to take into consideration. And that's how the speed of the robot you need to check. At the same time, you have to check with the cycle time, because you cannot compromise with the cycle time also, as it is a very important requirement of any system. So you need to check it whether the selected configuration will satisfy your cycle time or not with the speed. Then the vertical reach, as we discussed, this is the maximum height of the robo, which it can reach when extending its arm upwards from the base. So it is measured from basically the lowest point of the robot to the highest point of the wrist that can reach. On the same way, we have a horizontal reach. It is the distance from center of the robot's base to the furthest point the wrist can reach. So that determines the horizontal range of the robot's work envelope. Then we have degree of freedom. So you might have learned it into the theory of machines. So it is nothing but the number of independent motions the robot can have. It can be determined from the axis, number of axis a robot has. Then number of axis. So for some applications we can have three axis, for some applications we can have two axis, or some applications we can have six axis. So from that you will get to know how the robot will move into the space, what will be its work envelope, whether it will cover your work volume or not. So that's why the number of axis. Then the joints, as we discussed already, the links, number of links they are attached to each other, and those will form the joints. Then the singularity. Now this is one of the terminology which is very important, and that is nothing but a geometric constraint on the robot linkages, and that restrict then the linkages to move at some locations within the workspace, because of some restrictions. So these singularities are required to be avoided, because if you design something that will fall in these singularity space, then it will get failed. The robot cannot reach to that space, and that's how it will get failed. So these things you need to check in some softwares also. There are different softwares in which you can simulate all the things. Then comes, as we saw, the work envelope. So extension of that is nothing but the maximum envelope, restricted envelope, and the operating envelope. So what is the maximum envelope? So this is the outermost boundary of the robot's possible movements. So you can see over here. So that defines the maximum envelope where the robot can reach. It's like extreme positions where it can reach. Then comes the restricted envelope. So this is kind of a subset of the maximum envelope, and it is defined by safety devices or other limitations that restrict the movement uh, of the robo in this space. So is the area where the robot physically restricted to operate. That just what we discussed. So uh, you can see the restricted envelope and then the operating envelope. So it is the area within the restricted envelope that the robot is actually programmed to use during its operation. So it is the specific program path or region where the robot's movements are defined. So this is the um, operating envelope. So let's check out now. So this is one kind of a robo, and as we discuss some terminologies, let's try to find out over here. Now here are some basic things like which series, then version, then type. Now see the maximum load capacity at rest. That is what we discussed. given in the kg, and it is highlighted also. So this, that is one of the important parameter, and that is for this configuration, this robot, it is 16 kg. Then the reach, that is what we discussed, like how much its arm can move maximum in, let's say, horizontal direction. uh, and then this is kind of a vertical reach. Over here you can see the bottom of the robot to the this top, and this is like from center of the robot to the extreme end. This is kind of horizontal reach, and this is kind of vertical reach. Then the axis, what we discussed, number of axis. So it is having six number of axis. And then the repeatability, here comes the repeatability. You can see it is plus minus 0.02, that is 20 microns. That is the repeatability. Then here you can see the joints. So as we have the axis, it will form some joints. So it is having six joints, and these are given the motion ranges. That means at up to what angle these can be moved, these can be rotated or twisted. And same thing, the speed, that is what we were discussing, at how much maximum speed these things can be moved, because they will be having the servos or staples that are nothing but the control devices, and they will be having some limitations. Along with that, they will be having some mechanical limitations for the movement, and that's how the speeds are given, and then the moments are given. So these points will require at the selection how much maximum moment it can take at the joints, so that when you are designing the end of arm tooling, you need to check whether it falls within this moment or not. And some other parameters are given. So this is, you can see, this is kind of a work envelope. This is in a 2D, what but in upcoming series we will see how it is exactly in the 3D. Another example, let's say this is a two axis thing. So here you can see the descriptions, the axis construction, then the motor, you can see, or it is a servo driven. So then the repeatability, as we were discussing, again here the repeatability for x and y, it is having two axes. So for both axes it has been given. Then the maximum speed, again for both axes it is given, the ranges they have given, and here you can see the payload. So y stroke, as you are having more and more stroke, that will act as a cantilever, so you can see the payload capacity is decreasing. So that is also, you need to take into consideration how much stroke you have, and what is the payload coming. So these are some terminologies which are very important when we are selecting, or when we see the catalog of any industrial robot. So in our upcoming sessions, we will go in details. We will see what are the different configurations of the robots. So if you have any doubts, please do write into the comment section. We can discuss over there. Until then, keep intro making. Thank you for your patient listening. Thank you.